Here's section 7.5, where we define an isolated and a non-isolated system and talk about how each could be in a steady state. We want to understand that both zero energy transfers and equal and opposite energy transfers can result in a steady state system in terms of energy. So what does it mean for a system to be non-isolated? Non-isolated means that there's going to be energy transfers across the boundaries. So the change in the total energy of the system would be the sum of all of those transfers. To have an isolated system, that would mean that there aren't any energy transfers. So the total change in the energy of the system would have to be equal to zero. So the question is it possible to have a non-isolated system where there are energy transfers and yet have that non-isolated system be one where there is no total energy change, or be one where you have a steady state, essentially? That answer would be yes, if the energy that leaves the system has the same rate of change as the energy that is entering the system. Because remember, energy transfers could be transfers that are coming into a system and also transfers that could be coming out of a system. If each of these are the exact same value, just equal and opposite essentially, the total change in the system would be a total change of zero, and yet these transfers are actually occurring. So this would be a non-isolated system in a steady state. It's non-isolated because there are transfers between the environment and the system. That interaction is occurring, but it's steady because the total energy in the system would remain constant. So here's a few examples to give you an idea of what this might look like. This could be a home. In a house, we typically try to keep the temperature about the same for our own comfort levels, but we know that internal energy is coming into the system and leaving it. We may have the heat turned on in our home, and yet we're losing heat through our windows and our doors. So energy is leaving the system, and yet we continue to put energy into the system so that we essentially keep the place at the same temperature. The Earth's atmosphere is also a steady state system. Since it's surrounded by empty space or a vacuum, the only transfers that can occur would be through field forces like electromagnetic radiation. The Earth would receive and give energy in the form of E&M, or electromagnetic radiation, because the sun is inputting energy into the Earth, and the Earth is outputting infrared radiation from the atmosphere and the ground. The human body over several days is another example of this. With no major weight gain or loss, the potential energy stored as food and fat essentially remains constant, even though you have all of these transfers of you doing work, creating heat, generating mechanical waves of sound, even electromagnetic radiation as you put off a radiation that way in the means of, again, a sort of a heat that comes out of your body, or infrared radiation. As long as you keep putting energy in and replenishing the energy that you're putting out, you end up with sort of this steady state system.